Hello and welcome again to the MathTablet. This is the second session in our series called Factorisation, and in this session we're having a look at difference of two squares, which I tend to abbreviate to DOTS, difference of two squares. Okay. Now let's have a look at some examples here. With your factorisation of difference of two squares, basically your expression needs to look something like a difference of two squares, a squared minus b squared. How we factorise that is we introduce two brackets, okay, take the square root of the first term, so square root of a squared is going to be a, take the square root of the second term, square root of b squared is going to be b. Okay, so the brackets should look quite identical, except one bracket needs to contain a plus, the other bracket needs to contain a minus. So this is basically the rule that we will use when we've got a difference of two squares. Okay, now if we were to expand this one, let's just check. Multiplying this out, you're going to get a squared minus AB plus AB and minus B squared. So those two middle terms go. So you are left with A squared minus B squared. And that's why whenever we've got an expression that looks like a difference of two squares, we can factorize it by introducing those two brackets that look quite similar, except one has to be a plus and one has to be a minus. So let's have a look at this in action. Suppose we've got something like 9x squared minus y squared. Okay, so one look at that expression, I know that I cannot do a common factor factorization because there is no common factor across both of those terms. However, you need to recognize that, well, there are two terms. More than that, there's a difference between the two terms, and the two terms happen to be squared terms. So this is in fact a difference of two squares kind of factorization. So I'm going to introduce my set of brackets. Okay, the first term is going to be the square root of 9x squared. Square root of 9x squared, let's see, square root of 9 is 3, square root of x squared is x, which means that 3x will end up in the first part of both of those brackets. Then the other term in my brackets would have to be the square root of y squared. Square root of y squared is just going to be y because the square root and squared will cancel each other out. So I've got y happening in the other part of my bracket. Now remember, one bracket has to be a positive, the other bracket has to be a negative. It doesn't particularly matter which is which, as long as the signs are different, that's fine. So let's have a quick check of our answer here. If I were to multiply this out, that's going to give me 9x squared, that's going to give me positive 3xy, that's going to give me negative 3xy, which will allow those terms to cancel, and lastly I've got minus y squared. So I've got the 9x squared minus yx squared, which is what I originally started with. Alright, let's have a look at another example. So suppose we've now got something like, say, 25a squared minus 121b squared. So again, this is actually a difference of two squares. Okay, recognize 25 and 121 to both be square numbers. That's sort of your little clue. So introduce your two brackets here. Square root of 25a squared is going to be 5a, so that goes at the start of each of those brackets. The square root of 121b squared is going to be 11b, so that goes in the other part of my brackets. And then one has to be positive, one has to be a negative. Okay, and then let's just do a quick multiplication to check that that indeed works. That's going to give me 25a squared. That's going to give me negative 55ab plus 55ab, so that middle terms will cancel, and then negative 121b squared. So I know that factorization is correct. Now I just want to show you one more example here where we combine a few techniques. So suppose you've got something like 6x squared minus 6. Now on the surface it doesn't look like a difference of two squares factorization. Okay, the fact that 6 is not a square number sort of gives that away. However, in these sorts of factorization questions, you should always check first to see if there's any common factors. Here we've actually got a common factor factorization. We've got a highest common factor of 6. So my first step is actually to take out a common factor of 6 outside of a set of brackets. Right? Now, this is a difference of two squares factorization inside of the brackets, because we've got a difference in there. One is a squared number, and I can certainly take the square root of x squared. So this is a combination of techniques here. So what we're going to do is to leave the 6 where it is. With the brackets, treat it as you would a difference of two squares factorization. So introduce the two brackets. The square root of x squared is x, so that's going to go at the beginning of each of my brackets. And then the square root of 1 is just 1. One bracket has to be a plus, one bracket has to be a minus. Okay, so I want to emphasize here that this is what we would call fully factorized. Okay, whereas that expression there is only a partial factorization, and that's because we can go further without expansion, without factorization, sorry. So sometimes we can combine the two techniques together to get our fully factorized form. I hope you have enjoyed this session of the MathTablet.